Hello again and welcome. I recently made a video where I showed this engine on the right. This is an old MARX 999. I don't know when this was made, probably in the late 40s or early 50s. This was one of my trains when I was a kid growing up. I remember my dad taking me to an old farmhouse and we met with a lady who was selling off her late husband's train set. So my dad bought this for me. I don't know, I was probably 7, 8 years old or so at the time. And I've had it ever since, but I pulled it out about a month ago and it was in very rough condition. I thought I'd try to see if I could get this thing running again. The main problem was the bearings were shot. So you could literally grab the trucks here and they would just wobble. All the gearing was pretty wore, and there was a stud up inside of the motor here that had broken off. So these aren't worth a whole lot of money. I'd seen 3 of these up on eBay recently, all probably in better condition than this, and they were selling for under $30. So I had ended up buying a donor for parts, and luckily the donor had pretty good gearing. The motor was real tight. I had to disassemble the whole thing, but I robbed various parts between the 2 motors and I put it back together, and it seemed to run okay until it didn't. So what ended up happening is the stator winding shorted to the metal frame. So this is what the motor looked like that was shorted. And you'll notice they have this fiber washer. Notice how when this sits at rest, it's actually lower than the lamination. See that? So when they added their magnet wire over the top of this, that cut through this edge and shorted through to the frame. Now it probably was fine for several years, but eventually it got damaged. That probably was why the motor got put away in the first place. So these standoffs are riveted to the back plate, and you'll notice that they're machined such that you can't pull them through the laminations. So the only way to rewind this is to basically pull this entire assembly off of the plate. Of course, then you destroy the rivets. So I thought I'm going to be smart about this, and I took the other motor with the good stator and I took a Dremel tool with a cutoff wheel, and I thought I'm just going to cut right through this standoff. Then I'll grind it off on the backside and I'll pull this standoff through the motor, and then I'll machine a new one that doesn't have this standoff machined into it. I'll make a new standoff that slides over the top, and I can push this whole thing back together and it'll be fine. So I've got this cutoff wheel and I'm cutting through that rivet and I'm focusing on the blade of the rivet, not realizing I just ran that cutoff wheel right through the stator windings. So completely destroyed the second stator. So I thought, okay, the only choice now is to go ahead and remove the entire motor assembly. So I ended up leaving the 2 lower rivets, so these could stay in place, and just grinding off the 2 top ones. And that allowed me to slide the stator off of that back plate. So this is some of the original wire. I ended up going with a gauge smaller than this, and I used a higher temp wire. So I think I used like 22 or 24 feet of it. But before I did that, I took the other stator completely apart, and the first thing I noticed is, first of all, the fiber is a different color. It's a red tint to it, and it actually sits up higher than what this one does. But I still didn't trust it, so I ended up putting like 3 layers of Kapton tape and then wound over the top of that all by hand. And then when I was done, I covered the whole top assembly with Kapton tape as well. So this is the original stud that was in the engine that had broken off. Here you can see where I was starting to cut through it with the Dremel tool. So I thought, okay, we're going to have to save the other 2 studs off of the other motor. So I ground that basically as light as I could to get these things out. And then to reinstall them, I put them through the plate, and then I took a punch and I put divots around each stud to lock those back onto the plate. So it was a lot of work to put into an engine that really isn't collectible. And like I say, it probably today is worth about $30 at best. I was pretty hard on these toys. I used to treat them like race cars, so I would do pull tests with these where I would have two engines going against each other and we would have like a tug of war. The other thing I'd do is I'd drag race them like I would a slot car, for example. Of course, they'd go flying off the track, and this engine got some cosmetic damage because of that. I had also painted this engine several times. I think when it was all said and done, I had 4 different coats of paint on here. So I chemical stripped the entire top here. And then I hit it with a coat of primer and just shot it with this satin black paint. It didn't look right with the flat black, but you can see it's a little shinier than the original paint. So of course I cleaned up all the shafts, all the bearings. One of the set of brushes were good, so that's what's in the motor now. So this motor, as far as originality, these are the 2 original plates. It's got the original stator. This plate here is original that holds the brushes. The rotor is original. This gear is off of the other motor. The drive wheels and the shafts are off the other motor, and so are the bearings that went through them. So this is my first railroad track that I've made. These are some of the original pieces from my childhood. You can see on some of these rails where I've actually soldered wires to these. I remember having a book when I was a kid on model trains, and one of the things they were showing was basically pulling out the center pin and then basically powering up different sections of the track independently. So I'd use that technique to have multiple trains sitting on my track. Unfortunately, this track is in very rough condition. You can see I've screwed it to this block of wood. This end here is just going to be our stop. And then what I have off to the left is just a small scale. What I'm going to do is hook this up to our engine, and we're going to try running a pull test with it. So I bent up this little hook that we just run through the coupler. This particular scale will go up to 500 grams, and then I'll just mark this with this piece of foil tape. Let's just slow it down, and we'll see if that changes on the piston at all. Yeah, I'm going to say that's pretty close to the end. So it looks like between 210 and 220 grams. We could add some ballast. Normally for this type of engine, we'd want to put that weight right between the center of the 2 axles. It'd be a little difficult with this engine. What we'll do is we'll just add this into the rear. So again, this is where we were. Let's see if this makes any improvement. That's a pretty big improvement. So you can see that's gone to, looks like about 280 or so grams. So it's a fairly good increase. This is another old MARX engine. This is a 333. This engine, of course, weighs a fair bit more than what this 999 does. Let's see how it compares with no added weight. Holy smokes. can see as it bites in, actually pushes the gauge up quite a bit further. You could imagine if we added a little bit of weight on this. No, not a big difference. So I've marked it just about 380 grams, but you can see this thing pulling up over 420 grams, but adding that lead weight to the top of this didn't really make a whole lot of difference. Just an FYI, I'm running these trains actually off of DC voltage, not AC. There's a solenoid up in the front of this motor, same with this one here, so as you break the power, that solenoid changes a single pole double throw switch, and that changes the direction of the engine. The older transformers I had, they would use an AC plus DC mode with these, but you certainly could run these off of a DC voltage as well. One of the more interesting pieces that I have is this old banjo signal. This was produced by Lionel. You can see it has a red light bulb in here, and then as the motor turns, our little pendulum covers up the light. Looks pretty good. Now this no longer works, but what's real interesting about this is how it works. Let me just pop the cover here. We'll pull off the rotor. So there's not a whole lot to this. You can see it's just a coil, and you may say, well, that's not really a motor. To me, this was very innovative. What they had in here, unfortunately I can't find it, but there was a washer in here that had 3 little rubber nipples, and those nipples were sitting on an angle. So the way this worked, again, you're driving this off of AC, so that's pulling the plunger in and out like this, and those little rubber nipples act as a ratcheting system, so those push against the back side of this rotor and cause it to turn while it's vibrating in and out. I don't know when Lionel designed this. This is fairly old. Again, most of my trains were used. I had a mix of American Flyer, Lionel, and MARX, but most of what I have left are the old tin plate cars from MARX. I don't even have a control transformer for these. That's why I'm using a DC power supply. Well, I know that I don't normally produce videos like this on this channel. It's kind of like the blow torches. I just thought I'd share a little bit of old technology with you. Well, all for now. Hope you enjoyed the video, and we'll see you in the next video where we'll probably get back to multimeter testing. Later.